Sometimes we want to compare the efficiency of different treatment regimes. So this is very pertinent when we look at, for example, medical evidence, medical literature, and we want to compare how effective have different treatment regimes been in the management of a disease, for example. So we might have something like here where we have an intervention or no intervention, an intervention, and we compare positive outcomes with negative outcomes. And this could be, for example, patient survives and here the less fortunate outcome. And how do we actually compare these data and make sense of it? Well, what we can do is we can use the concept of odds. And in odds, we just simply calculate the positive outcome divided by the negative outcome. So in this case, for the case without the intervention, and these would be patient numbers, for example, we would have the odds of a positive outcome for negative intervention would be 125 over 250, and that would be 0.5. In the case of with intervention, we have 250 over 125, and that gives us a factor of 2. So the odds of being okay without the intervention is 0.5. The odds of being okay with intervention is 2. And what we can do now is we can form what is called the odds ratio, usually abbreviated with OR, where we just simply take usually it's the higher value and divide it by the smaller value. So this would be odds 1 divided by, or rather in this case it would be odds 2 divided by odds 1. And as I said, we usually use the higher number. It's just a convenience. So we would have 2 over 0.5. And that gives us an odds ratio of 4. So in a way, this tells us really that we have a factor of 4 that the intervention has a positive effect on the outcomes. That is basically what the odds ratio tells us. Now, of course, we want to see whether this is sort of meaningful. So what we want to do is we want to calculate the confidence interval, and very often we are not just dealing with the odds ratio. Very often we use, instead of the odds ratio, we use ln of the odds ratio. What does that mean, and why do we do that? Well, let's put it this way. If the odds ratio, let's assume the odds ratio is 1, what does that tell us? Well, the odds ratio of 1 would tell us that both methods, with intervention and without intervention, lead to the same odds. Because 1 would be 1 divided by 1, so it would be the same odds. So an odds ratio of 1 would not have any effect. The treatment would lead basically to the same numbers. ln odds ratio, if we have an ln odds ratio, and in this case of 0, because ln 1 would be 0, again, this means exactly the same thing. Treatment has no effect. Treatment, no effect. That is basically what these odds ratios tell us. And very often people work with an ln odds ratio, because it is easier to plot. It is just simply there is a straight line going through 0 if there is no effect. Anything that is above 0 means there is an effect. Anything below 0 for the ln odds ratio means there is no effect. Now we've got an ln odds ratio of 4. So in our case, we have ln of 4, and that gives us, when we put that in the calculator, 1.4 for the odds ratio. Now we want to calculate a 95% confidence interval, because the ln odds ratio or the odds ratio just give us a point estimator, and we always want to look at confidence intervals. And this is actually quite easy to calculate. So it would be ln of the odds ratio plus minus 1.96 times the standard error. That's the standard error. And the standard error in such a case is very easy to calculate. It is the square root of the individual cells, of the reciprocal of the individual cells. Let's call that A, B, C, D here. So it would be 1 over A plus 1 over B plus 1 over C plus 1 over D. And we can quite easily calculate that. So we would get here equals 1.96 times square root of 1 over, what was it, 125 plus 1 over 250 plus 1 over, that was 250 plus 1 over 125. And when we do that, this gives us 1.96 times 1.9 times square root of 6 over 250, if I'm correct. And that gives us 0.3. So for this expression here, we get 0.3. So we can write our 95% confidence interval, ln of our odds ratio plus minus 0.3. Now we just calculated that to 1.4. So our odds ratio, the odds ratio would be between 1.4 minus 0.3 and 1.4 plus 0.3. So that would indicate our confidence interval, and I should say this is the ln odds ratio. And we could easily convert that. We can say, if we are interested in the odds ratio, for the odds ratio, we would just have to take both, values e to the power of, so the odds ratio would be between 1 to the power of 1.4 minus 0.3 and e to the power of 1.4 plus 0.3. And if we put that in the calculator, we would get something between 3 and 5.5. So that means that the treatment has a positive effect, and it is 3 to 5.5 times more efficient than no treatment. So this is basically what we can do with the odds and an odds ratio, and how we can calculate a confidence interval of an ln odds ratio. It's important that we can do the confidence interval only with the ln of the odds ratio. So this equation here that we employed, this equation here, is only valid for ln, but we can easily convert the ln into the odds ratio just simply by taking a to the power of this confidence interval. So I hope this makes sense, and thank you very much for watching.